Welcome to this video on scientific notation, where we'll look at converting numbers with both positive and negative exponents into and back out of scientific notation. We'll start with the number 1.27 times 10 to the 3 and explore how to move this out of scientific notation. To understand how to move this out of scientific notation, we have to understand what 10 to the 3 means. And 10 to the 3 is 10 times 10 times 10. It's 10 times itself 3 times. 10 times 10 is 100, times 10 one more time is 1,000. So what we really have here is 1.27 multiplied by 1,000. And 1.27 multiplied by 1,000 equals 1,270. So 1.27 times 10 to the 3 is 1,270. Most often, when people explain how to take a number out of scientific notation, they just say if the exponent is positive, move the decimal to the right, and if the exponent is negative, move the decimal to the left. Let me quickly just explain why this works. 1.27 times 10 to the 3 is the same as 1.2 times 10 times 10 times 10 3 times. So if we go one at a time here and multiply by the first 10, we end up with 12.7 multiplied by 10 multiplied by 10. Multiplying by this second 10, we end up with 127 multiplied by our remaining 10. And finally, multiplying by our last 10, we end up with 1,270 again. Whenever we have a positive exponent, we've taken tens out, so our final answer is bigger than the value we have in scientific notation. So we have to put these tens back in. And every time we put a 10 back in, it moves our decimal place 1 point to the right. And this is why people are often told, if you have an exponent of 3, you move the decimal point to the right. So 1.27 times 10 to the 3, our decimal starts here. We're going 1, 2, 3 decimals to the right. Here's our new decimal point. I always say if you have a basket without an egg in it, you have to throw an egg in it. So our final answer is 1,270. And now you know the why behind we move the decimal to the right whenever we have a positive exponent. Let's now explore why we move the decimal to the left when we have a negative exponent. What a negative exponent actually means is that the value is in the denominator. So 3.26 times 10 to the negative 4 is actually 3.26 divided by 10 to the power of 4. And as we've just seen, 10 to the power of 4 is equal to 10 multiplied by itself 4 times. So this is 3.26 divided by 10 times 10 times 10 times 10, which is equal to 3.26 divided by 10,000. And 3.26 divided by 10,000 is equal to 0.000326. Now the ironic part is if I put 3.26 divided by 10,000 in my calculator, it's actually going to give me 3.26 times 10 to the negative 4. It'll give me the answer in scientific notation. So let's now explore how we can actually get this decimal if that's what we need to answer our question. For convenience, let's just work off of this step right here. So let's divide by these tens one at a time. If we divide by this first 10, 3.26 divided by 10, we end up with 0.326 divided by 10 times 10 times 10, the 3 remaining tens. Dividing by the next 10, we end up with 0.0326 divided by the 2 remaining tens, 10 times 10. Dividing by this 10, we end up with 0.00326 divided by our last 10. And finally, dividing by our last 10, we end up with the same answer we did up here, 0.000326. So as we've shown now two different ways, when we have a negative exponent, our beginning value is bigger than our ending number. So we're taking factors of 10 out. We're dividing our starting number by 10 depending on the value of the exponent. And every time we take one factor of 10 out, our decimal point moves one place to the left. This is why they say when you have a negative exponent, you move the decimal point to the left the same amount of times as the number of the exponent. So when you see a number with a negative exponent, you're just moving the decimal point to the left because we're dividing by 10 or taking out factors of 10 the same amount that you have for the value of the exponent. So writing 3.26 without an exponent, we're dividing by 10 4 times, so our decimal moves 1, 2, 3, 4 positions to the left. And if you have a basket without an egg in it, you throw an egg in it. So our final answer here, showing a third way, is 0.000326. And now let's quickly just look at moving numbers back into scientific notation, which is really just doing the opposite of what we've just done. If you have a number such as 23,600, we need to take factors of 10 out to put it into scientific notation. So if we divide by 10, we end up with 2,360. Dividing by 10 again, we end up with 236. Dividing by 10 again, we end up with 23.6. And dividing by 10 one last time, we end up with 2.36. Looking at how many 10s were taken out, we took out 1, 2, 3, 4 10s. So when we write this in scientific notation, we need to put these 10s back in. So 2.36 times 10 to the 4. We don't have to go through all this. Every time we take a 10 out, it moves the decimal point one place to the left. So if our decimal is here on 23,600, we took out one factor of 10, 2, 3, 4 factors of 10. Here's our new decimal point. So we have 2.36 times 10. How many factors of 10 did we take out? We took out 1, 2, 3, 4 factors of 10. So we have to put those factors of 10 back in when we write the number as 2.36. And we apply the opposite if we want to take a small number and write it in scientific notation. So here we have 0.0053. So we multiply this by 10 once and we end up with 0.053. Multiplying by 10 again, we end up with 0.53. And finally, multiplying by 10 one more time, we end up with 5.3. So to get our value of 0.0053 to 5.3, we made the number bigger. And we made it bigger by 1, 2, 3 factors of 10. So when we write this number in scientific notation, we have to make sure we take these factors of 10 back out. So we have 5.3 times 10 to the negative 3. So this is how we write a small number in scientific notation. We add factors of 10 by multiplying by 10 until we get to the number we want, and then we take those 10s back out by multiplying by a negative exponent. So we move the decimal point to the right in this case. So if we start with a number of 0.0053, we multiply by 10 once, twice, 3 times. Here's our new decimal point. Our decimal point is now moved to the right. And we end up with 5.3 multiplied by 10 to the negative 3. We take out the same amount of 10s we put in. Thank you for watching this video on scientific notation, where we explored why the decimal point moves to the left and to the right when we're moving numbers into and out of scientific notation.